All right. Starting off to talk about technical interview overview. When you are going to apply for a job, you build a resume, you look for jobs on sites like LinkedIn or Glassdoor or Stack Overflow, not Slack Overflow. And then you start talking to recruiters. When they're interested in your application, they'll reach out to you and schedule a call. If you want to hear more about what's involved in that call, you can check out our event from 2 weeks ago. That's posted on the Women Who Code YouTube channel. I also have a link in the previous event description to just a short version of that talk. If you're interested, let me know and I can send those links at the end of this event. Next up is a coding evaluation. This can take a lot of different forms. It depends on the company, it depends on your role. The goal here is that the company wants to understand, can this person do what we need this person to do? And it can be short, it can be long. I've seen all kinds of different things come up here. 3 of the most common things that I've encountered are online coding challenges. This means you'll go to a website like HackerRank and you'll be given 2 to 3 problems and you're told to solve them within an hour to 2 hours. Once you're finished with the problems, you submit them and results are sent to your potential employer. You don't always get to see the results, which is kind of makes me a little bit nervous when I see that. But afterwards, the company will reach out and tell you whether you passed or failed and whether you're going to move on or not. Next is the technical phone screen. This is the most traditional type of job interview for the first stage. You would get on a phone call with an engineer or a manager, whatever role you're looking for, and it will be a 45-minute to 1 hour long call where you're sharing an IDE. So maybe Google Docs. 5 years ago when I was interviewing, people used Google Docs. Now they use integrated IDEs online. So you'll be pair programming and running code. And after that, they'll usually ask a question like the technical interview questions I'll be presenting today. Finally, there's a take-home coding project. The way this works is they might give you like a zip file or a tar file and say you have 48 to 72 hours to implement this in that project. Examples of this might be, we have a service and we have 3 APIs. None of the APIs are implemented. Implement as much as you can, send it to us, and then we'll have a 1 hour follow-up call to discuss what you wrote. So that's another style of coding evaluation. Once you're done with that first hurdle, there's a next stage where they do further evaluation. Sometimes you'll end up with something called a soft skills interview. This is where they try to evaluate what kind of leader you are, how you handle challenges, how you like to work on a team. This can range from what are your thoughts on DevOps and code reviews to how do you handle conflict and influence your coworkers to follow best practices. So it's a big range. What we traditionally see when we talk about FANG companies, so Amazon, Google, Netflix, is something called a full day onsite. I have this in quotation marks because no one is really doing full day onsites right now. Initially, when COVID started, people would do full day remote onsites. So you would have 4 to 5 hours in a row of interviews nonstop. Now that we've moved to remote, some companies are breaking that up. So you don't really have a full day and you don't have onsite anymore. But the way it works is you start early in the morning and then you finish in the afternoon. And by the end of the day, you have done maybe 4 coding problems, a system design problem, and often they add the soft skills interview in there too. After all of these potentially 6+ hours of coding evaluation, you'll end up in the offer negotiation stage. Today, I'll be talking about total compensation and benefits and how that can impact your offer negotiation. You can do the evaluation of benefits and compensation as soon as you have the benefits information from your recruiter, which is something you can get in the initial recruiter call. Once you have finished your offer negotiation, you've looked it over, everything looks good, you move into paperwork, references, immigration, background checks, all that kind of stuff, and then you have a job. So I've highlighted what I'm talking about today. If there's anything in this particular flowchart that you want to see more of, or you want to see sooner rather than later, let me know, and we can get that scheduled in another event. Okay, So totally understanding benefits and total compensation. I am going to work on answering a few of these questions, actually all of them. What is the difference between base pay and total compensation? How do I calculate my total compensation? How do I use my total compensation and base pay to compare jobs? And do I negotiate for total compensation or base pay? Total compensation, roughly speaking, is everything you get from working for the company. This can be financial, money directly in your pocket. It can be side benefits. So usually when we talk about compensation, we focus on base pay. That's at the bottom left corner here. It's actually quite important. It usually is a majority of your compensation, but there's a whole bunch of other things there too. You might have other monetary benefits added to your compensation, like RSUs. RSUs are restricted stock units. If you have this, the company will give you stock in that company. So for example, you joined Facebook, they give you Facebook stock. Things that have monetary value but aren't directly money are things like free lunch. They're not necessarily giving you $10 a day for lunch, but you're saving that $10 by working there, assuming that you are eating lunch on campus, which right now no one's really doing. And finally, there's things that I call perks. When somebody uses the term perk, it's pretty open-ended. Some people will consider free lunch a perk. I consider perks things that don't have a really easily determined monetary value. So if you can bring your dog to work, it's kind of hard to put a price tag on that. And I'm going to talk about how to incorporate all three of these different types of things into your calculation of total compensation. Don't worry too much about the crazy amount of words on this particular slide. The key thing here is that there are three groups of things, and you want to turn them all into dollar amounts. So the first category is what I'm calling what you're paid. And this is pretty easy. They're already dollar amounts. So these are things like your salary or base pay, any 401k matches, any sort of matches on contributions, either 401k or HSA, restricted stock units or bonuses. This is dollars that you can count your company's giving you. Then there are things that you don't have to pay as a result of these benefits or working at that company. They can be things like your medical insurance premium, relocation costs, a commuter card. So these are things that, yep, I can look at it and say my commuter card costs $100 a month. I can add that as a number to my base pay. And then finally, there's this other group of things that's really hard to wrap your head around sometimes, and it's what you will have to pay as a result of having this benefit plan or moving to that company. Two good examples here are medical and work from home. I'll start with work from home because a lot of us have suddenly found ourselves in that position. You suddenly started working from home and now you realize that you don't have a camera, you don't have a second monitor, your external keyboard isn't really good. So now you have to buy all of these things or just suffer through it. So that's something you will have to pay as a result of maybe changing to a job that's primarily work from home. Some companies will reimburse it, some companies won't. And that's why you look at this in terms of total compensation. Another example is medical. So when you look at different medical plans, you might end up paying more or less as a result of having the plan, but you still don't pay the insurance premium in either case. So the actual monetary value you calculated yourself as getting might stay the same, but what you end up paying in a year is different between the benefits. So this one's a bit tricky, but it can have a huge impact. When you have benefits, they're all supposed to sound great. They're all supposed to sound like, you want to take this job, why would you say no? It's amazing. But some of them come with a catch, and some of these catches are actually really important. I'll go over a couple of them here. So the first one is the term prorated. Often they won't actually say prorated. If you ask them about it, sometimes the term will come up. It basically means that you're going to get a benefit, but it's spread out over time. For example, if you get a $12,000 signing bonus and it's prorated, you'll get $1,000 a year as it's prorated over a year. The scarier version of this is you get all $12,000 on your first day, but if you leave after 6 months, you have to pay back the $6,000. Oh, sorry. So this can sometimes happen with relocation expenses. So for example, if a company like Microsoft says, we'll move you to Seattle, But if you leave before 2 years, you're going to have to owe back that, $6,000 move or parts of it. So that's kind of scary. It's always worth checking on those ones. Next is vesting. I am not a financial expert, but it's important that you understand the concept of vesting when it comes to stock and any stock awards. This usually applies to 401ks and RSUs. So if a company says we're going to award you $10,000 in restricted stock units as a signing bonus, that is not $10,000 that you get in your bank account when you join. Often it has a vesting period, maybe 2 to 4 years long. That means that you'll have $10,000 allocated to you, and over the next 2 to 4 years, pieces of it gradually end up in your account. The reason why this type of thing is important, just like prorated, is if you're comparing two jobs and you want to say, what am I going to make in a year? Well, this $10,000 is actually $2,500, rather than the $10,000 signing bonus that you might have had from another job in cash. Performance-based. These might sound scary, and they should just a little bit. It's not terrible. Basically, there's benefits that you can't really get unless you're a good performer. This can be things like transfers or ranges and bonuses. When a recruiter tells you we have up to a 15% performance bonus, it means that you're probably going to get somewhere between 0 to 15, and it depends on your performance. The tricky thing here is if you don't know how your performance, you are evaluated in terms of performance, you're not going to be able to know whether you're doing well or not doing well. So you'll find out, you want to transfer, and then suddenly transfer is denied because you didn't understand how the performance system worked. So in some cases, this can feel out of your control. So just be aware that this can fluctuate. So if you're saying, I'm banking on having a 15% bonus every year, just be careful because you might not get 15% every time. I will get to vesting once I finish the other two. It's definitely a hard topic. It took me years to figure that one out. Next one is tenure-based. Just like performance-based, you'll often be told, you get this bonus, it's great. Or more often, you get up to 20 vacation days. When you look at the fine print, it says you get 20 vacation days after you've worked here for 2 years. Well, that's not really what I was looking for. Maybe you want to change jobs every 2 years because you want to get more experience, or you have a short attention span like I do and you end up quitting every 2 years anyway. So this can be really important, especially when, again, you're comparing what will I make at this company for 5 years versus 2 years. That can have an impact. Finally, this isn't directly a catch on the benefit itself, but it's something that can really significantly impact your annual spending. If you are changing benefits, going from one company to another, or you have a different set of benefits when you're unemployed versus employed, the actual change can cause a problem. The most concrete example is your commute time. So you get this amazing job and you get paid more in terms of your base pay, but you now have an extra 30 minutes of commute each way. So that's an hour of your time over the entire business year. Multiply your hour by how much you're paid, and maybe it's not actually much of a gain there. Or on the other hand, you might say, I love commuting on the bus. It's when I read. So it's really up to you how much of a disruption it will cause. But you want to make sure that any of these changes, you don't regret and say, now I've been spending, $500 more on gas and parking as a result of changing this job. So that disruption can have a high price tag. So I see that, okay, Daniela, thanks for linking that information, or for adding that information about vesting. I can't think of a great example there. So the idea is that, maybe you're at a restaurant and you've ordered something. So you're getting pasta, and back in the kitchen, they've allocated some pasta to you, some pasta sauce, maybe some mushrooms and onions. And so all those items are allocated to you, but you actually don't have them yet. It's not until time goes by, the pasta cooks, the mushrooms are chopped, a whole bunch of things have to happen before it's actually ready to be given to you. This is a bit of a shaky metaphor, but you know that those ingredients are allocated to you before it actually gets to your plate, but you can't eat them until it gets to you. So this idea of vesting is, again, it's taken me years to figure it out, and it applies to 401ks and RSUs. The most frustrating thing is that you're going to look at your investment account or your retirement account provided by your employer, and it'll say you have $10,000. And you're like, great, I'm going to leave. You quit, and that drops to $3,000. So it's something that you really want to know about. You don't have to be completely thoroughly versed in it, but just know that anything that vests, you might lose if you leave. Okay. So I've had some conversations myself on both sides of it where I get an offer from a company and I'm really excited about the benefit, or maybe someone I know gets an offer from a company and they're really excited about this benefit. And so this conversation happens. I have a new job and it covers public transit and parking for work. Isn't that great? You know, it's awesome not to have to worry about that and improve my budgets. And someone just sort of asks, you know, don't you live a 10-minute walk away from your office? And I think, well, yeah, but you know, what if I move someday? And so this is an illustration where you get this great benefit. Like I've seen companies that are like, you get to learn a language for free. I'm like, oh yeah, that's great. I've always wanted to learn a language. But if I'm not actually going to use it, if it's not a real benefit to me, then I don't actually get any value. So if I'm not using my commuter card, I'm not saving $150 a month. It's just this benefit that's kind of around. So you can exclude that from your total compensation because you're trying to tailor your total compensation. And I'll talk about these two different things. You can tailor it to your lifestyle, or you can just do a raw sum of values. So this gets into the question of how much is this worth to you? So I'm going to go through a couple examples just to sort of get your thoughts going on it. But really, when you have a benefit, like something like learning a language or bringing your dog to work, for someone who doesn't have a dog, bringing your dog to work isn't super valuable. And if you have dog allergies, that may even actually be costly because you're buying allergy medications to go to work. But for someone, it can be extremely valuable, meaning that you don't have to leave work so quickly to get home, or you can stay for happy hour at the end of the day. So going through a few examples like that. So an extra day off, you think, okay, the standard calculation is how much am I paid an hour approximately, and multiply that by 8 hours for my vacation day. Seems fine. And that's a good estimate. But for some people, that might be something like when I go home for the holidays, I can travel a day earlier, which means that my ticket is going to be 75% of the cost back in the days that we traveled. And so that can have a much more significant impact. So an extra vacation day can be a different value for different people. Free lunches, again, this one, you're like, okay, work days times 10 or 15, whatever the costs are where you are. But it also means you don't have to do grocery planning. You don't have to fight for space in the refrigerator. So for some people, again, this might have higher value. And this is all part of comparing different benefits across multiple offers. Gone over bring your dog to work. It's one of my favorite benefits. I don't have a dog, but I love it when my coworkers have dogs. Mother's rooms. So this is actually a really interesting example. For someone who is a nursing mother, it is really critical to be able to have a mother's room. Just like if you are in a wheelchair, you would love to have a ramp and accessible parking. And so this is sort of an example of something that you may take for granted, but your company may or may not have. So it's something to identify about what your needs are. And you can also use it as a negotiation point. So if I'm a nursing mother, I need a mother's room and I don't want to be like running back and forth or rushing, maybe you have the option to work from home for half the day, or maybe you can work from home for a period of time. So this can be something like, I see that your campus does not have this facility. Will you allow me to work from home? So again, these are sort of negotiation points that you can bring up. Free conferences. This is one just like the commuting conversation. People have said, you know, my company pays for conferences. And I'll say, oh, what conferences have you been to this year? And they're like, oh, you know, I'll go to one next year. So I love going to conferences. Really the biggest problem for me is that my bosses won't let me take as much time off as I want to go to all of the conferences. So this can be really high value, or it can be basically, you know, you live 10 minutes away walking and you have a commuter card. Shorter commute. This is actually, like I said, this is the easiest to understand. I don't know if you haven't been on public transit during rush hour. It is a physical and emotional journey to just get from one place to another, even more so these days. So shorter commutes can have really high value to people. Sometimes being able to walk versus driving, and if you're driving, being able to have parking. So this one's a big one. Always take a look at it. And I'll bring this up near the end. If your commute is changing, and you say, you know what, can I work from home in the morning so I can not leave during rush hour, or can you pay for my parking? And so this is, again, a conversation point where you can say, as a result of changing jobs and moving to your company, I'm actually going to be really inconvenienced. And then work from home. I think everyone has had some experience working from home, maybe not necessarily working, but being productive in some way, if you haven't been in the workforce yet. Prior to COVID, I had to really fight to be allowed to work from home. So this has been like this amazing change that I absolutely love. So if working from home, years down the line, if working from home is important to you, you really want to bring it up. Sometimes it's one of those tenure-based or performance-based options. So companies may say, well, if you've been with the company for 5 years, you can work from home. And you're like, well, that's not going to help me with my puppy, let me bring my dog to work kind of thing. So these are just sort of examples, like trying to be creative and thinking about different aspects of your life and how they might be impacted. So here are 2 different ways you can think about comparing total compensation. So the first one that I've been sort of focused on is you can add up all the monetary benefits, add value to the non-monetary benefits, like not having to rush home to walk my dog is worth $100 a day. And then you can add them all up. You end up with a single number. It's relatively easy to calculate. Like, I don't think it's easy, but you get a number. But the problem with that is you potentially mask higher costs to you personally. So this is where that sort of, changing the medical plans, my medical premium is still covered, but it turns out I'm spending 2 hours commuting every month if, you have to see a doctor that often. So here's a sort of cost of living version. This kind of requires you to be tracking your spending, so you can, look at your banking tools and see where you spend your money in a year. So for example, you might have a gym that you go to and you pay $600 a year to go to this gym. Or you have a retirement plan or you have a medical plan. As a result of changing jobs, how does this change your spending? So if a company offers to reimburse all my fitness expenses, or they have an on-site gym, that means that I'm not spending that $600, and I can either allocate it somewhere else, I can save it up to take a trip, I can put it towards a down payment. And so then you end up with this new budget of how much you're going to be spending each year and how much you have as non-allocated cost of living income. So that's another way to calculate the value of this set of benefits. So this can get really complicated. Like, medical benefits are just, really hard to calculate. Some benefits guide actually go through like multiple scenarios. But there are, other benefits like commuting and things like that. The other thing is, if you are moving, so if you're relocating from Philadelphia to Seattle, this sort of cost of living calculation will more accurately reflect, like, is your rent going to be higher? Are you going to be paying more for food? In the reverse sense, if you move from, Seattle to Buffalo, do you now have to pay for snow tires? I'm not saying Philadelphia, because in the year that I've been here, I haven't seen enough snow to need snow tires. But there are these things where your actual budget is going to change potentially. So that's a more comprehensive way of looking at how total compensation affects you. But it is harder to calculate, and you kind of have to have some idea of how you spend your money. So I'm going to give a somewhat contrived example of comparing a low base pay offer and a high base pay offer that have different benefits. Spoiler is that the low base pay ends up having the higher total compensation, and we'll see how that breaks down. So here you have a base pay of $90,000 a year versus $100,000 a year. We get some restricted stock units in both cases. This one is $10,000 over 2 years, so you can average that out to being $5,000 a year. And the high base pay option has $10,000 over 4 years, so now you have $2,500 a year. We look at our 401k matching. This is pretty standard for 401k matching. It's yet another of those really complicated financial things that after a few years, you figure it out. The short story is they give you free money. And in this case, it's $2,400 of free money, and here it's $1,500. So there's that difference there. Relocation. Relocation is a really interesting benefit. At least it was before March. So companies like Google, Facebook, Amazon, they really strongly believe that having people on their campuses made people better at their jobs. Things have changed a little bit. At that time, you had two options usually. You got a lump sum of money, so maybe $2,000, and whatever, you can keep that money if you don't spend it. So if you're a college student moving a couple of boxes across the country, that $2,000 sounds great. You get to keep $1,500 of it after you pay for your plane ticket. Or if you're moving a family of 4, you get all of the relocation coverage. That can be, I'm saying 5,000, but it can be like 8 to 10,000, depending on how big your house is. And so this is a lifestyle change, you know, whether you're even relocating change. And so it can be a significant difference for this particular benefit. I'm sort of glossing over medical a little bit. I've sort of shortened it to what's your deductible. That just means how much are you paying. So this is a minus. So you have an idea of how much you're going to be spending on medical needs in a year. According to this plan, I spend $1,000, and according to this plan, I spend $3,000. There's extra stuff around HSAs. So an HSA, often an employer will, it's another way to get free money. So in this particular plan, you would get $500 from your employer towards medical expenses. You have to pay $3,500 out of pocket, so it ends up being minus $3,000. Again, there can be a whole hour-long talk about medical plans. Then we have a couple of these other benefits: free parking, on-site gym, free lunch, travel reimbursement. Some companies in the travel industry offer that. Company discounts. Company discounts is one of the best ones when it comes to, you know, I get 30% off high fashion clothing and I'm wearing t-shirts and jeans, and it's sort of like, okay, well, you're not really using that benefit, are you? So when it all comes down to the bottom here and adds up, you end up with, maybe $5,000 to $6,000 more in the low base pay option. And you think, well, like $5,000 to $6,000 more, like it's smaller than the taxes I pay. But then you look at it over a few years. If you're planning to be at this job for 5 years, maybe that adds up a little bit. Maybe it turns out you can afford a down payment a little earlier. So this is definitely something to consider. I haven't really called this out, but having a good idea of how long you're going to be at this job can also impact how you evaluate your benefits. So I'm going to wrap this up and talk about how all these different ideas and calculations can fit into negotiation. So there are a couple, so when I find negotiation hard, I don't want to go to a recruiter and say, I see that you offered me 90,000, please give me 120. That conversation feels really awkward. I don't even know how they feel about that conversation. So there's some ways that you can use this benefit information to try to adjust your compensation. So you can ask things like, I'm switching to your medical plan. It's going to cost me an extra $5,000 a year. Can you increase my base pay by this amount so that I can not have to pay these expenses? This one I have used and it has worked. And so I got, an extra 5,000, which honestly, 5,000 again, it's not like you're going to retire next year, but it's something. And when it comes to salary negotiation, raising your base pay is great if you can, because your base pay for your current job often impacts your base pay for your next job. But getting an increase in total compensation works as well. So another example is if you have a competing offer and parking is free because they own the office building, and you say, if I take this offer, I'm going to be saving $10 to $15 a day. Can you add that to my base pay as compensation, or are you able to give me free parking? I've had jobs where after I started, they told me, around the water cooler, They said, oh, if you ask for free parking, they'd give it to you, but they don't offer it up front. So you could potentially end up with new additions to your total compensation or your base pay. It might be either. And finally, going back to the commute option, if my commute's longer, I need to pay for an additional hour of daycare, so I need a Y dollar increase in my base pay. Daycare has been a really interesting topic in tech, where a lot of people have asked for on-site daycare on campuses like Google, Apple. Definitely a battle, but you can always try to ask for adjustments to your base pay because of the inconveniences to your lifestyle. So this is all I have on this topic. I am just going to see, Danielle, are there any questions? Okay, so I am just going to reshare the link for the to everyone for the interviewing IO, just in case anyone missed it. I sent a whole bunch of links all together, so it's a bit confusing. So that link is back in the chat.
Hey, Alicia, I did have a question.
Yep.
Sorry, I was too busy being hilarious in the chat. In the very beginning, when you had that flow chart, and you talked about that full day on site, and I apologize because I wasn't able to make it to the last one. Do you, like, is it unreasonable? Because you said, like, it could end up being 6 hours long, and you're programming for a lot of that. Like, that's valuable time, and time is money. So is it unreasonable to ask for compensation for that full day on site?
Usually, no. It's not like it is definitely frustrating because you end up having to take a day off of work, which is why recently, if I want to do interviews and they say, please schedule your 4 to 5 hour on-site interview, and I say, can you do it over 4 days and do like 1 hour a day? And the recruiter thinks for a little bit and then says, yeah, we can do that. Like, we're not in the office anymore. But no, you don't end up being paid for that. I think one of the riskier ones is when you get a take-home coding project and you're asked to actually implement like an API. I've had some people say, are they just like ask me if they're using me for free labor? So that one, you know, it's always this concern of, I'm spending so much time interviewing for you. What do I get in return? Yeah. Sometimes you'll get free lunch, which is not really worth it.
Yeah, it's like there's no guarantee of a job offer.
Yeah, so. And in my experience, you get these types of full day on-sites at larger companies who, I don't know, maybe they have the reputation to motivate people to have that level of stamina. So,
yeah,
you know,
they're doing you a favor by letting you in the door.
Exactly, yeah. But smaller companies, it's been, you know, really casual conversations. Interviewing with startups, it's, you know, I show up, we all hang out in the room, maybe have lunch together, and we talk about code, and they say, yep, you're hired. So I've had some a lot of variety. And so if this idea of a full day on-site of, you know, I have to say, a lot of times the interview rooms do not have good ventilation, so you got to bring raw water. Sometimes they're too cold. And so you've got to bring sweaters. You have to make sure you're in layers. So if you get too hot, you know, pick a shirt that doesn't show sweat. Like it's bad. But if that's not your thing, you don't have to work at companies like that. On the other hand, if you want to work at one of the top tech companies, you're looking at something kind of ridiculous. So one of the, as you know, as an aside, a lot of people have observed that the traditional tech interviews like this are broken. They don't evaluate you for on-the-job skills. We're constantly doing these algorithms and data structures, conversations and studies and books, but really when it comes down to it, if you can figure out what the package conflict is in your Node application to get it running and deployed, that's way more important than, you know, determining if there's a cycle in a linked list, which is a problem we will go over today. So if you're feeling like that's dumb, who do they think they are? A lot of people are with you there, and people want to change the script on that for sure.
Yeah, it's like I get why, you know, like the data structures and algorithms are important and all that stuff, but like also, like, I'm not specifically planning to go into data science, so I don't see myself really using it in everyday programming heavily. So,
It does come up, interestingly. Uh, Usually, when we talk about data structures and algorithms, we look at them in this very sort of bare form. This is a tree, this is a list, this is a, I don't know, array. And you're like, okay, I can see that in isolation. But they're very disguised when you actually interact with them at work. So for example, I worked on a natural language understanding product. They called Alexa. I don't know if you've heard of it. It's hard. Bad joke. But we use trees like for everything. Now the technical term is finite state transducer, but it's a tree. And you would traverse the tree and you would evaluate different, leaves and edges as you go down to a leaf of a tree. And you kind of have to know what that data structure is in order to understand how, yeah. So you're like, okay, well, that's a weird place for that to show up, but just these really interesting cases. Hash maps everywhere. Like,
yeah. So like more a matter of like knowing the basics and recognizing them in your code, your everyday code. Okay.
Yep. Being able to discuss. So this is something where you're like, you talk about hash maps, which is what we talked about before, and collisions are really important. So like, oh, there's a collision, I'll just add it to a list. But if you're in a database and it's like, you're trying to store all the customers at Amazon in this map, if there are collisions and you have to search through a linked list of thousands of customers, well, those customers are going to be waiting like 10 minutes to load their web page. So these concepts, how it behaves, and how they interact with each other can be really important. I'll talk a little bit about travel itineraries as an example here, but travel itineraries come up in graphs all the time. Different links, where you can get flights and where you can't get flights, the cost of the flights, optimizing, you build a site that's trying to find the best travel deals. You have this graph of flight paths and you have to search through them. So I would say that every time I code, I'm not like, yep, I'm, bringing out my depth first search and my hash map collision resolving mechanisms, but it does come up from time to time.
Okay.
That being said, the difficulty and impracticality of a lot of the difficult interview practice problems is just, it's ridiculous. I think that they don't actually evaluate skill. If you want someone who spent 100 hours doing problems on LeetCode but can't communicate and is unable to come up with creative solutions, then I don't really want to work at your company. So the interview process can tell you the kind of people you'll work with. Everyone has their own opinion. Sometimes the challenge of that level of problem solving and getting all the right answers is really motivating for people. But I agree, there's definitely opportunities for improvement in how the tech interview does interviews.
Okay.
All right. Wonderful sidetrack and discussion. Thank you, Meg. And I'm going to move on to lists and arrays. So I'm going to interleave these two different topics. Hopefully it's not too confusing. So I'll first talk about arrays, and then I'll talk about lists. So like define arrays, define lists, and then I'll go into examples of each. Arrays are an ordered collection of elements accessible by index. Okay, thank you for coming. I'm just going to go. No. So arrays are, to keep in mind, is an ordered list of items that come one after the other. And I'll show you some examples here. And there are a few special things about arrays. One thing to note is they're very language dependent. So these next 2 points, and I'll go into them a little bit, are language specific. So often all the elements of the array are of the same type and the array is of fixed length. This means that if you're in a language like Java, you say, I have an array of 6 integers. It doesn't get bigger, it doesn't get smaller. There are always 6 integers. Some languages don't have a separate array type to a list type. so you don't really see that. So Python, it's really hard to like interact with an array because they just have lists and it works for both. The other piece is that we talk about memory being contiguous. So for arrays, especially in languages like C, C++, Java, you have the memory pointer to the start of the array, and then you say, what is my data type? I have an integer, it's 8 bytes times 6. So that's how much memory I have, and it's all allocated. And so I have this chunk of 6 times the size of an integer in memory. That means that if I want to find the third element of this array, I just do integer size times 3 plus the start index, and you're actually kind of manipulating pointers in memory. And so that makes it more clear why it's fixed and why it's efficient to access them, but you can't change its size. And finally, to add more mind-blowing concepts, you can have one-dimensional, two-dimensional, or n-dimensional arrays. I have never had an interview where I've been asked to do anything with an n-dimensional array, like 3 or 4-dimensional, but it will come up in things like acoustics and graphics, which luckily I haven't done too much with because I find that to be very finicky and mathematical. A couple of terms. So elements, we call those the items or objects in arrays. We have an index. Index is the location. So we talk about zero-based indexes. So we have, we have this string called tacos. T is at the 0th index, so that's the first one. In some very special cases, you'll have one-based, but it almost never happens. So if you want to talk about data structures, you can say, is this 0-base? Almost always it is. When I went to university, all the engineering buildings had 0 as their basement, and all the arts buildings had B as their basement. Just a coincidence, I'm sure. And when you talk about dimension, it's sort of how many nested arrays there are, but the shortcut is how many indexes do you need to use to get to an item. So when you have a 2-dimensional array like this, you need to have index 1 and index 0 to get to this white one here. So in this example, it's 3-dimensional. In this example, it's 2. And then contiguous again, it's a weird word. I don't think I've ever used it outside of this context of contiguous memory. And just looking at these examples a little bit, strings are often character arrays. So you can access strings like you would arrays if you've noticed, and sometimes it's because they're the same data structure underneath. And this is a 2-dimensional array. I want to call out that this is a sort of a black X. And you'll often encounter 2-dimensional arrays when something like detect how many shapes there are in this image, or determine a path on this map that's represented by a 2-dimensional array. So you can look this up. I don't have the link to it, but it's like a flood fill problem. And that's sometimes you use 2-dimensional arrays to determine how many shapes there are. That's something I would consider a harder problem.
Alicia, you just kind of like hack dropped something like nonchalantly. You said strings are made up of the same data structure as an array.
Depends on the language. So if you, and again, I do apologize for bringing up Java.
Went on. I was like,
yeah.
What?
So when you look at strings in some languages like Python, you can access the characters of those strings like you would an array. And in Java and C++ and C, they're actually arrays in memory. So they work the same way.
Oh.
And so the reason why I bring this up is because if you're in a language where they're similar and you think, wow, I use strings like I use arrays, it's just a point of interest. It's not usually something that comes up in interviews, unless you have a really terrible interviewer that's checking for trivia and not actual skill. And I forgot to link the Wikipedia page for this into the chat. I'm sure you can search on Wikipedia, but I figured I would share. So switching gears to linked lists, and I'm calling out this is a linked list. There are other types of lists depending on your language again. but we almost always talk about linked lists. I'm not going to go into the other types, language specific. Definitely take a look at your favorite language documentation. So this is another linear collection, just like an array, but the difference here is it's not contiguous. So you can't look at the next memory address to find the next item. Instead, the next item is determined by the current item. It says, I know where the next one is. I will tell you. And that's a link. So it has sort of like, imagine you are pointing your finger at someone. You know who the next person in the list is. And so determined by a reference rather than something adjacent in memory. So all these overly technical terms sometimes come up. So more vocabulary, just like with the array, you can call it an element, but often people will use the term node and element interchangeably, which is something borrowed from graph and tree language. Link or pointer. So a link is how you determine which next node is, and sometimes we use pointer because you'll think of it as a memory pointer. If you're not familiar with memory pointers, then you're probably using a modern language. Sentinel, this is not usually the most common word to come up. It's basically a dummy. So if you have an end to your list and you're looping through your list and you don't want to get a null pointer exception or an invalid value exception, you put a dummy node or a sentinel node at the end to say you're done. And so that's what the sentinel node does. Head or root. The head of the list is usually the start. Again, borrowing from tree language. Sometimes people call it a root. Most of the time, people call the end of the list, but occasionally the term tail will be used. Some examples here. So you can think of a flight itinerary as being a flight from Philadelphia to Chicago to Seattle. And Chicago, if you arrive in the Chicago airport, in terms of the flight you're on, it doesn't really know necessarily where you came from. It doesn't really matter. But when you're flying from Philadelphia, you're like, I'm definitely going to Chicago. And so that's sort of one representation. And you see that it ends with a null. So when you get to the end and there's no more elements, this is a null, but you could also use a node that's like end of list node. This is in contrast, so the flight path is one way, but you might have a COVID video game where you're doing a map of your house, and so you can go between certain doors. So your kitchen can go to your living room and your front yard, and your front yard can go back to the living room, but apparently you can't get, nothing can lead to your kitchen. So you could represent this as a map, and here the important thing is that it's doubly linked. So I know where it can go, and I also know where it came from. So the kitchen, if I end up in the living room, I know that I can go to the front yard, and I know that I came from the kitchen. So it's an idea of you're pointing to the next person, but you can also turn around and point to whoever's behind you. The final type of linked list is a circular linked list. For this example, you might be in a fulfillment center and you're packing boxes. So you can start off by taking a box, taking an item, pack the item, tape the box, add a label, ship the box, and then keep going until the world ends because nobody's going to stop ordering packages online. The key thing here about the circular linked list is there's no null, there's no start or end. Often you will keep track of what the first node is and then just go into it, or you just cycle through it forever.
With the doubly linked list, can you I noticed there's one direction with the other two, but you go to the kitchen, the living room, and then go back to the kitchen?
Yeah. So you would think of it, maybe this isn't the best example, but you can think of it as a playlist. So if you're on Spotify and you're listening to a radio station, you can only go to the next song. So that's a singly linked list. But if you have a playlist or you're on iTunes, you can go to the next and the previous. Okay. And so that's sort of the difference between singly versus doubly linked list. You have a sequence, and you can either only go to the next one or you can go back as well. And this can impact the performance of certain solutions or algorithms. You can imagine if you're trying to do a binary search on a linked list, it would make it a lot easier if you can go back and forth versus, maybe not binary search. Sorry, I'm just improvising here. But doubly linked list is you can go forward and back. Singly linked list is only forward, and you can't really know where you've come from or how you can get to that. Does that clear it up?
Yeah, so you can go like kitchen, living room, front yard, living room, kitchen, living room, kitchen.
Yep.
Yeah.
But
okay.
in the singly linked list, you can't go from Chicago to Philadelphia, and Chicago doesn't even know that Philadelphia can get there because the link is stored. So this arrow here is part of Philadelphia, and so that's kind of a key point. Chicago is its own item, and the link to Seattle is there, but Chicago has no idea that something is pointing to it. So imagining a line of people where you're pointing to a person's back, they can't see you. You know who they are, but they can't tell that someone's pointing at them.
Okay. Oh, that's crazy. So like, oh. So even though, well, in that circular list then, can they tell, since it all connects, can they tell what's pointing to them because it goes, like references back in a circle?
It depends. If it's singly linked, the tape box, these nodes have no idea they're in a cycle.
Oh, wow.
And so,
okay.
yeah, so one of the problems I'll go over is detecting a cycle. But these nodes are just nodes. This step is, I know I need to tape a box, and after I tape a box, I have to go to add label, but that's all the information it has. It has no idea how big the list is. It doesn't know how many steps there are, if there's a cycle or not. Of course, you can customize your implementation to start tracking this information, but in the bare form, you don't have any idea what the list is that you're in. So you have no information about what's around you. And you might think, this is, Wild West of data structures, but it means it's really easy to add and remove because these are not contiguous in memory. You can add some items over here, over there, and you don't end up having to consume a lot of cycles reallocating memory. Now, in a lot of modern languages, people aren't using memory directly. So the value of arrays versus lists isn't always as apparent anymore. But if you do anything with C or C++, that's when it comes into these comparisons.
Okay. Thank you.
A circular linked list. So this is where things get interesting. If you think of a linked list as a set of nodes with pointers, then yes, it is a graph. The restriction here is that it would be a very specific one where it's linear, so you can only point to one other item. So just to answer that question in chat. But it gets weird when you interchange things. So I'm like, oh, I have a node and I'm looking for the child node. Oh, by the way, it's a linked list. And people will be like, I guess you can say that, but you're talking like it's a graph. So yes, in some applications, they can be almost identical. I'm going to move into time complexity. I'm just going to grab a link to a Women Who Code presentation on Big O notation and link it in the chat. If you're not familiar with Big O notation or time complexity or the asymptotic behavior of an algorithm in terms of time and space, it's a whole other presentation. The short answer is the bigger my data gets, how does that affect how much space and time this takes? So one example might be, you're trying to drive to work. If you have one person in a car, it takes you one trip. If you have 10 people, it suddenly takes you 2 or 3 trips, and that increases the time by a lot that you have to get to work. Not, a great example in terms of asymptotic complexity, but you've written an algorithm. It may actually take longer with bigger pieces of data. When I talk about this complexity, and if you are studying for interviews with a bunch of different data structures, it's useful to pick a specific set of operations that you're going to be using for comparison. I usually pick insert, get, delete, sort, and search because it becomes really clear when you compare it to other data structures. And so search is probably one of the biggest ones when you get into more complex data structures. I'll go over these though. So when it comes to insert, in the array, I mentioned that it can't grow and it can't shrink. So when you talk about insert, it's not really adding anything, it's just replacing. But that's constant time because, again, you just need the initial memory address, add the size of the data, and that's a constant time operation. Similarly with get. With delete, though, again, you can't delete anything from an array. It's fixed size. Sorting, choose your favorite sorting algorithm. N-log-N is the best, reasonably the best for arbitrary data. So that might be quick sort or merge sort. Search, if you're trying to find an item, that will take you maximum, you have to look at every single item. For linear data structures like lists and arrays, you're looking at O of n, but when you get into things like trees, it becomes a little different and you can optimize, especially if you have a binary search tree. N space is O of n. This is pretty boring. It's going to become a little bit more interesting when we talk about lists. Just to keep in mind that whatever the size of data type times the number of pieces of data, that's how much memory it is. Looking at lists, same operations, space is a little more interesting. So we have insert, which is O of n, get, which is O of n, delete, which is O of n. And that seems pretty bad. Everything takes n time. Why would you use a list? This is where the asterisk comes in. When it comes to any of these operations, they can be insert first, insert last, or insert at index. And that means that if you're inserting first, it's constant time because you create a new node, you change its reference, and you're done. Similarly, insert last could be O of n because you have to go through every single node to get to the last pointer and add a new item. Or if you keep a reference to the last item, then you can just make it O of n. In general, the worst case for all of these is O of n, so you have to look at every single element in the list. But in specific cases like insert first or delete first, it can be a lot faster. And searching and sorting are about the same. Because these are both linear data structures, it's kind of boring, they're very similar. But as you look at other data structures over time and comparing them in different problems, you'll see different patterns emerge there. And just to compare to hash maps are constant time for insert, get, remove compared to lists, but searching a hash map also takes O of n, potentially, depending on how you're searching. So some comparison there. When you look at the space, so the best thing here to think about is probably databases, which may or may not be something you've used before, but you have a single database table and all of your elements are in there, but it's really hard to change the size of the table because you have to have a fixed set of columns, but everything's all together in memory, so it's kind of like an array. But now you're thinking, you know what, I want to add a customer profile to my shopping website, and I don't want to keep it in the same table. Instead, I'm going to have a link to another item. Or maybe instead of having everything on a block on disk, I'll store a customer profile and it will have a link to the next one. So no need to keep everything in blocks. Instead, I'm linking to the next piece of data. And that means that you can store the data anywhere you want. You're not restricted in terms of this table is too big. But the problem is every time you store a piece of data, you're also storing a link. So if you have a singly linked list, you have your data plus one link. If you have a doubly linked list, you have your data plus two links. And you're thinking, you know, the links can't be that big. And normally they aren't. But if you're talking about small data types like integers, sometimes the links are integers too. So they're just pointing to a specific location. So for an array, you'll have n integers, so it's n bytes. But for a singly linked list, you have 2 times n bytes. And for a doubly linked list, you have 3 times n bytes. So this is important when you talk about comparing arrays and lists. Most of the time, the value you get from the flexibility of having links is greater unless you're on like a constrained device like a cell phone or an IoT device. So that's sort of how lists compare to arrays in that sense. Most of the time, you don't need to worry too much about that, but it's worth knowing if it ever comes up in a database discussion. So I'm gonna check. So if anyone has any questions about time complexity, it is really fast to have to go through all of these. I'm gonna Okay, I don't see any questions. And Daniela, did I get them all?
I
They don't have any questions. Go
I
ahead.
I like have gone over space and time complexity with like some of my friends from Flatiron, and like I'm sure you know a lot more about it than I do. But there is a resource that I put in the chat that's a Big O cheat sheet, and they have different values than you do. And
It depends. So
yeah.
it really depends on the way you're discussing it. So like I'm looking at some of these, they do average and worst. And so, and some of them use theta and some of them use O. And so they're all different. It's all kind of gets complicated. So I can take a look, but a lot of it's debatable. So I can say search is O of n, or it's log n if it's sorted, or get is O of n, but it's O1 if it's the first. And so there's a lot of qualifications here. So often it's worth talking about what it is that you're doing with this data. So I'm trying to see well, we can talk about it later. If there's time at the end, we can talk about which ones are different.
Okay. Yeah.
But yeah, I'm seeing them and I'm like, yeah, everything says O of n because when in doubt, well, okay, don't always say O of n. Don't always say the worst complexity because it may not be the right answer. No n factorial here. Okay, so I'm going to move into the practice questions. So there's 2 practice questions. The first one is, given an array of integers, so we're going to start with arrays, write a function that determines if there are 2 numbers in the array that sum to k and return their indexes. I have a typo there, but I'll live. So the way this is going to work is you've got this array of integers and you're given a number 9. I want 2 numbers that sum to 9. Looking at this array, I can see that 2 and 7 sum to 9. So I'm going to return 0 and 1 because 0 and 1 are their indexes. Let me just get you a link to that problem on LeetCode because that is where I took this problem. Okay, are there any, well, I'll actually get into the problem, we can go into questions. So whenever you get an interview question, you want to ask questions back. So you want clarifying questions on the problem, trying to air out any assumptions or try to get more information about the solution. Does anyone have any ideas on what are some clarifying questions you can ask? I have some prepared. This is not a sliding window problem.
Are we assuming that there's only one set that could add up to k?
That's a good one. Duplicate elements, that's a good one as well. Thank you.
Can you go back to the problem?
Yeah.
Thanks.
Yep, negative numbers, that's a good one. Are you good on that, Meg?
Oh, yeah.
Sorry, just want to make sure that if you needed time to absorb it. Empty array, yep. So these are some clarifying questions I prepared. Unique solutions, multiple solutions, we talked about those. Integer overflow, this one's a funny one. Computers can count numbers, but they have a limited amount of space for how big the number can be. So if you add the 2 largest numbers a computer can hold, you get something called overflow, where it's like, this number is so big that I can't add it anymore, and you get a really random number, or it seems random number as a result. So you can talk about integer overflow. Positive and negative numbers, zeros, can numbers be reused, and what happens if there's no solution? So there's a whole bunch of questions you can ask to try to get a better idea of what your answer is supposed to look like. If you go to the LeetCode page, you can take a look after. The LeetCode problem is also linked in the event description if you miss it in chat. But it tells you a few of the answers to these. So it says things like there's exactly one solution and you can't use the same element twice, things like that. But definitely worth, when you're practicing interview questions, try to practice, and before you read past So HackerRank gives you all the assumptions, and so try to block that off and then think, what would I ask an interviewer? Does anyone have any quick suggestions on what a solution might be? I kind of gave it away here, but there's two solutions to this. So solution one, I'm calling nested loop. So unfortunately I gave that one away, but if you have ideas for how that solution might work, feel free to send it in the chat or jump on unmute. Okay, so the idea here is to have a nested loop. The first step is you're going to look at each element in the array. And then you want to search the array again for the other number. So I'm going to go through each number and say, this is a 2. And then I go through the array again and say, I'm looking for a 7. And so that's one way you can do it. This solution looks like this. So I realized that, here's the solution, bye, not very helpful. So you're going to have this loop. So for each number, give me the index and the number, because remember, we have to return the indexes, not true or false here. So once I'm looping over the first number, I then want to go look at every number after that to see if I can add to k. And this is interesting because instead of going from 0, I'm going from I plus 1. When you think about how many times am I comparing two numbers, if you compare the first number to every other number, you don't have to compare any other numbers back to the first one because those pairs have already been looked at. So this is an optimization. It doesn't really change the time complexity, but it improves it a little bit. So I'll talk about that in the time complexity analysis. And when you get the second number, you say, do these sum to my target? If so, I return the 2 indexes. In terms of what to do if you've looped over all of them, you can't find something, one option is to throw an exception. Another option might be to have a null. Another might be a pair that's -1, -1. So there's different options there. This one has an exception. So looking at time complexity, we have our first loop, and we go over that n times, where n is the number of elements in the array. Then we have our second loop, where we loop over that n times as well. And so you have outer loop of n, inner loop of n. When you have nested loops, you multiply their complexity. So it's n times n, or n squared. As I mentioned, this isn't exactly n times. It'll be n minus 1, then n minus 2, then n minus 3. But when we talk about time complexity, we sort of say approximately, or what is the behavior of that function over time. And so overall, we have quadratic or n squared complexity. And we haven't added anything new in terms of space. So our space complexity is constant. Very rarely, interviewers will say, well, what about the size of the input? And then you're like, okay, well, yes, the size of the input is n. I've only had that happen a couple of times, but sometimes it's worth saying the input is of size n. Any questions about that solution? Okay. We're going to go to solution 2, which is called the complement solution, or which I'm calling the complement solution. So Daniela, I think you might have been referring to this one. So here's a hint before I give the answer. You know what number you're looking for. So if you're trying to sum to 9 and you have 7, you know you're looking for 2. So the complement of 7 is 2. So if I had some way to know if I'd seen a 2 before and where it was, then I can more easily look up where that number is, where my complement is. So that's sort of the basis of this solution. Does anyone want to suggest what the difference would be here? So I'm gonna let you know I'm using a different data structure. Does anyone want to tell me, give a suggestion on what that data structure might be?
Would it be like a hash map of like a difference that it would take? Like it would be an assigned value for each value of what it would be to make k?
Yep, so we're going to definitely put the complement in a hash map. It's going to be a little bit different, but we're definitely using hash maps. So the way this works is we start as before, so we're looping over each number. And we're going to have a map where it maps from the complement to where the complement is located. if the complement is in that map, so if I'm looking at 7, I'm like, I need a 2. If 2 is in that map, I get 2's index, I use it with 7's index, and I return it. If 2 isn't in the map, I say, well, there's no 2, but maybe there's a 2 later on that's looking for me, 7. So I put 7 in the map, and I put its index there so that it can be looked up later. So that's sort of the gist of it. It's a longer solution, or at least I added more spaces and comments in this one. So I'll go over this. So new to this one is we're creating that map. And again, that's going to be the number to its index. So we're kind of creating a map. Where do I find this number? And we enumerate over the indexes and numbers again. But the first step is I'm going to determine what I'm looking for. So if I'm on a 7, my complement is going to be a 2 if my K is 9. I check if the complement is in my complements map. This notation is it's supposed to be more human readable. Apologize if it's sort of confusing naming pattern. So if my complement is in my complements map, I found my match, I return my index, and I return the index that was stored in the map. Otherwise, I add myself to the map so that someone else can find me later.
I think, like, now that we're going over this, I think I've done this before, and I named the map scene. So they were like numbers I've seen.
Mm-hmm. Yeah, naming is definitely an art.
Yeah, it might help. Like,
yeah,
that's like it's a difficult like thing to think of. Like,
new to coding. Yes, map and dictionary. Sorry, Meg. But yes, naming can help. So first, I have seen job interviews where people answer questions and they only use single letter variables. I'm like, I'm sorry, I have no idea what's going on. Naming is important in a job interview. And Jolene, to answer your question, you can use the term dictionary for Python. If you use dictionary in other languages, it can make sense, but often it's called map instead. There's a lot of different terms. Some people will say hash map, hash table, dictionary, or just map. So yes, dictionary and map are equivalent when it comes to Python. Okay, so time complexity and space complexity. So first off, we have storage this time. So we're creating a data structure, and that's going to be a size n maximum. So if we do a loop over every item is going to end up in the complements map. Since this always has a solution, you're probably not going to have n items, but the worst possible case is n or n-1. Next, we are doing our loop, and that happens n times maximum, so for each number. And everything else in here is constant time. So constant time doesn't mean that it takes no time at all. It just means that there aren't any inner loops. So this is constant time. Assigning here is constant. One thing that you might catch on is it constant time to check if an item is in a map? Yes, because of the way hash functions work. You take the number, you hash it, you look for the item, if it's there or not. But if you happen to be tracking this in a list instead, you would have to search that whole list. And if you go through the time complexity of searching, that would then be O of n. So be careful about your helping data structures in loops. So that we end up with linear time complexity and linear space. So this is more time efficient than the first solution with nested loops, but it is less space efficient. So there are two different options. Next, I'm going to do, I haven't seen any questions on that. Feel free to post them and I can check. But in the meantime, I'm going to put up the next problem. Given a linked list, determine if there is a cycle in the linked list. So we talked about cycles before. Nodes don't know they're in or elements don't know they're in a cycle. But we want to determine if our singly linked list has a cycle. Though, I mean, this is a clarifying question. You say, is it single or double linked list? For this problem, it doesn't really matter. But it's definitely something you can ask. Let me get a link to that problem. Okay, so in our examples, we have, maybe some flight itineraries, and we have an itinerary with no cycle. So we go Philadelphia, Chicago, Seattle, and then we carry on with our life. And in this sort of nightmare situation, we have a flight path where we go to Philadelphia, Chicago, Seattle, Phoenix, Las Vegas, Houston, Los Angeles, and back to Phoenix. And we're forever flying between these 4 airports. So cycle detection can have value. You don't want people in infinite flight paths. So we want to solve this problem where we determine if there is a cycle. Clarifying questions. Does anyone have ideas on what clarifying questions they might ask?
Could you put it back on the other screen?
Sure.
Could we have multiple cycles?
Yeah, so you might have a list with multiple loop-de-loops like this. For that particular case, we would say, we're looking for any, so finding any is fine. Duplicate nodes, that's good. Are all nodes unique? That would certainly be confusing. Again, when you look at the LeetCode problem, they start giving you some of the answers to these questions. So they have a constraint section. So again, if you're practicing, try to hide that before you get going. What are you returning? Always asking for the return value. That's really helpful. Knowing whether you're returning the first element in the cycle or whether you're returning true and false.
We also need to know like the restrictions on the number of elements, because like a cycle would start at 3 elements in the list, right?
You could have a single node pointing to itself. It'd be really weird, but you could have that.
Wow. Okay.
Yeah, it's. I know you'd be like, why would anyone do this? This poor little single cycle node, or single node cycle. But all these are great questions. So I haven't covered all of them, but I've got a few. So return value, that's a good one. We're going to return a Boolean in this case. Will there always be a cycle? What do you return if there isn't one? So I kind of answered that one with this first one. So if there is a cycle, you return true. If there isn't, you return false. What format is the input? So there's this particular question is you can be given a list, like a list data type, which wouldn't really make sense in terms of this problem, but in general, if you're doing list problems, you want to ask, is this a list like a Python list or a Java list, or is this something you're giving me a custom class? In a LeetCode problem, it gives you a custom class, which I'll show you on the solution slide. Single or doubly linked. Again, for this problem, it doesn't matter too much, at least not for the solutions I'm using, but it's worth keeping this in mind when you have any list problems. And then how is the end of the list indicated? The assumption is that it's probably null. So if I hit null, but maybe they have sentinel nodes or dummy nodes, maybe they'll let you choose. And so that's another way to make sure that if there isn't a cycle, you know that you've hit the end. Does anyone have any ideas on how you might solve this problem?
Can I ask one more thing?
Mm-hmm.
So if you don't hit null, but you hit a sentinel node, like how would you know?
Right. So sometimes you might have sentinel nodes, like for example, if you have an array of cities and that's your flight itinerary, then whenever you hit a node that doesn't have a city or it's empty, or maybe you say Mars, you have a sentinel value, or it has like end, then you say, okay, I've hit this end node, and now I don't go anymore. Again, it's one of those cases where you might not want to have pointers to nothing, or you might not want to handle null in your program. And so you have these dummy nodes that say, I am the end. And sometimes it can be a value that's like, I am the end. Yep, Daniela, I'll be doing the fast slow as the second solution. Sorry, was somebody speaking? Okay, so I'm going to get into the first of two solutions. So the first one is tracking visited. So it's kind of like that complement solution where we start tracking where we've been and what we've seen. In the top right here, we have this custom class. And so you have a list node, it has a value and a next. And so you can access those directly. So similar idea, where we're gonna try to keep track of where we were. And the solution is kind of, once I say we're gonna track where we were, you keep looping over the list until there are no more nodes in the list or no more elements in the list. But as you loop over each element, you say, have I seen this before? And you keep track of that in a set. If you haven't seen it before, you add it to the set and you keep going until you've either seen something twice and you return true, or you hit the end of the list and you return false. I have this red asterisk here. We'll talk about that in a sec. So this is a solution. Again, trying to space it out so it's a little more readable. So first off, we want to keep track of what we've seen. And I want to be clear that this is a set and not a list. And the reason for that I'll get into in this for loop here. And then normally when you're looping over lists, linked lists, you get a current pointer. So current is what I'm currently looking at. For whatever reason, it's become sort of a normal, like the standard variable name you use. And then we've passed in head, which is a term that I mentioned before is used for the first element of the list. And keep, like, note that you don't actually have to pass in anything other than the first element, because that element can tell you where all the others are. So it's kind of an interesting property of lists is you're basically passing a single node and that tells you about the entire list. So we have our while loop. And in this case, we're going to keep checking to make sure that we have a valid node or element. So as long as current is valid, I'm going to keep looping. And current could be invalid if it's none. So in this case, we're saying if it's a null or none object, then we've hit the end of the list and we need to stop. So skipping there, if we are no longer at a valid element, return false. So that's the end of the while loop once you've exited. So if we're in the while loop, we check to see if this is something we've touched before. So if current is not in scene, we add it. Now we know we've seen you before. Otherwise, it is in scene and we return true. You could invert this if statement. I'm thinking maybe it would have been better as an inversion, but maybe next time I go over the solution. So that's sort of the basics of it. And then once you've determined whether or not you've seen it, you advance your pointer. So current equals current.next. So our new node becomes the next node, and then we keep looping. Taking a look at this top right list node definition, by default, self.next is none. Don't worry too much about the initialization, but if you are at the end of a list and you go to next, it might return null or none, and that's why we have this while loop condition. So tell me when I've reached the end of the list. That usually means that either my next node is none or I'm none in this particular case.
Is this Python?
Yes.
Okay.
Sorry, I chose Python for brevity, but sometimes it's kind of wordy. I could go with JavaScript or Kotlin next time for a variety.
I was just wondering what language it was.
Sorry if I forgot to mention that. Okay, so time and space. Here we're creating a set, so we've got n elements that we're storing, and we've got a constant current pointer. We have our for loop over our entire list potentially, so that's O of n. And I again want to draw attention to this. So your scene data structure. So just like before, if you're keeping track of it in a list and you have to search the entire list, this current not in scene is actually going to be an ON squared loop, or sorry, ON loop. So you're actually doing another loop inside. So this is just to call out, be careful about using built-in methods in your language of choice. If it actually has added time complexity, then you might not have an ON algorithm, but an ON squared. So that's just something to keep in mind. Because I'm using a set, or sometimes they're called hash sets, it's not looping over the whole structure. At least from what I understand of Python. It is entirely possible that I'm wrong, but that's how it works in Java. And so this is what you get for switching between languages all the time. But that's just something to be careful. If you are using built-in functions, make sure you understand the complexity of those built-in functions. So we've got linear time and linear space, which is nice. So that scene set that we have, and then without any hidden nested loops, we have O of n for time.
I have a question, Alicia.
Mm-hmm.
So we're using the scene object, and you said once we've seen a node, then we put it in, and if we see it again, then we return true. So are we assuming that no two nodes have the same value? Or is that possible in a linked list to have the same value of two different nodes?
It does, and this is one of those interesting pieces. So for this particular example, you could have two nodes that have the same value, but as objects, they're different objects. But if you're dealing with like integers directly, then you might have duplicates. So in this sense, there are no duplicates. So to make that a little bit easier, you can say there's no duplicates, but when it comes to these links, they're actually memory addresses. So the only way you could have a duplicate is if it's the same location in memory, which means it's the same object. This gets into sort of lower level implementation of languages. But if you define your equals function in your list node to be this.val equals other.val, then yes, you would end up with a duplicate. And that would sort of be up to the design. And so you could definitely talk to your interviewer about it and say, what is the equals method like here? The assumption that I've made, which I didn't call out, which is good that you brought it up, is that we're comparing the memory locations, not the objects themselves. Does that make sense?
Okay,
Probably.
so by us storing, okay, so we do scene.add of the current, like, because you mentioned the memory that we're storing that's placed in memory.
Yeah. So it's like, you know how whenever you go through a coding class, they talk about variables. So you have like a bunch of jars, and each jar has an integer. Instead of comparing the integers, we're comparing the jars.
Okay.
If that makes sense. So you could change it, so you're comparing the values instead, but that depends on the description of the problem.
Okay. And could I assume that in this case, like memory would be their indexes where they are, or no? Like where they are within the list?
Not quite. So if you've ever done debugging and you've just like printed an object and it's like object at blah, blah, blah numbers, and you're like, that's not the value. That's just like a dump of numbers. That's actually its memory location. And so when you are comparing these two objects, it's saying, are they located in the same spot? This gets a little more complicated. Like this is going into how languages track objects and references and manage them. So it's location and memory, but what you can consider is a list node. You might compare the values, but in this case, we're actually considering each list node as a distinct being, and two may have the same value, but they're actually distinct entities. Does that make sense?
Yeah, that does.
Okay.
Thank
If it
you.
takes a while to make sense, apologies. There's a lot to computer science, it turns out.
Thank you.
It really helps too, because like I struggled with that same concept, and like Ruby's my main language, and it helps to like just like make an object in like a sandbox and duplicate it, and like bring up like the like print out the object, and you'll see like what she's talking about with that string of numbers. It shows like the actual memory location, and you can see like everything else is the exact same except that string. So it's like checking the values, like the content of this object versus the memory location.
And it will also depend on your language. Python is nice about, trying to print something readable, but other languages aren't. So just definitely look at how you can take a look at unique identifiers for your objects. Got it. So I'm going to move on to the second option. And this is something Daniela mentioned in chat. So we call it fast and slow pointers. I'm noting that this one's a little more space efficient. So to get this image in your mind, you have a race and people are running around on the track. When the slower people are running and the fast people are running, eventually the fast people are going to catch up to the slow runners and pass them. And so in this way, you have fast and slow runners. And you know that if it's a cycle, if it's a track, eventually the fast runner will catch up to the slow runner. Yes, unless it's not a cycle, in which case the fast runner will end the race and go to their beer garden, and the slow runner will eventually catch up. However, if it is a cycle, then they're going to meet at some point. So that's sort of the premise of this fast and slow pointers. So the idea is, how do we get two runners running on this linked list and find out if they meet? So first is you set up a fast pointer and a slow pointer. When I say pointers, it means that they are references to existing objects, but I'm not creating a new object. So I'm not creating a new list element. I'm just pointing to an existing list element. So when you loop through these, so you're moving from one element to the next element. And as long as the slow pointer and the fast pointer haven't overlapped, so if you're on your track, maybe your track shoots off to the side. So if the fast runner never gets to the slow runner, there's no cycle. But as soon as they meet, you know that there's a cycle because they're starting to lap the other runners. So if they're different, so you're checking, where's my slow runner, where's my fast runner? They're not in the same spot and the fast runner hasn't ended the race, then I'm going to advance them. So I'll advance the slow runner 1 and the fast runner 2. So then the fast runner just keeps jumping. When they show up at the same element, so you get that lap point, then you know there's a cycle. Otherwise, the fast runner ends the race and there's no cycle. I like this solution. It comes up in some other applications, but it can be take a few minutes to let it sink in. So this is the solution. In this case, it's a little more important to check if your input is none. And you'll see that in the next lines. So here I'm setting up my fast pointer and my slow pointer. So my slow pointer starts at the beginning at space 1, and then my fast pointer starts at space 2. And that's why I checked if the input was none, because I wouldn't be able to do none.next here. So this has to be something to set up the fast pointer. So then, while the fast runner hasn't met the slow runner after going around them, and if I haven't reached the end, so you check if the fast pointer is none. That means that you've hit the end node, or the fast.next is none, so I'm right before it. Then you can say, I reached the end, there's no cycle. And the fast runner is going to get there before the slow runner. If you haven't reached the end and you haven't lapped, then the slow runner goes to slow.next, so it advances forward 1 space. And the fast runner goes next.next, so it advances forward 2 spaces. And that's why in this if statement, you have to do fast and fast.next aren't none. So as you loop through this, you're either going to hit a point where you've hit the end and you return false, or the while loop exits because the fast and slow pointers are the same. So they're now at the same spot in the race and you return true. So that's the other solution. And for time complexity, you take a look at space, and it's constant space, which is nice. So that's a little bit different than the last one. And we still have a loop over n elements. And you might say, does it really loop over n elements? Because how long is it going to take? Because like the fast pointer has to go over all of them and then catch up to the slow pointer. So it's true that it might not be exactly n elements, but it behaves like O of n. So it's again part of the asymptotic complexity. So you end up with linear time and constant space, with the asterisk on linear time, where when you look at the other solution, you're probably going to find that there's a cycle faster in that solution. So even though they look the same in terms of, oh, they're both ON, they're slightly different. And then with space complexity, this one's space efficient. So in applications where you're thinking, you know, how do I detect a cycle, but I can't use any memory, you might use something like this. Any questions about those? I like the fast, slow pointer solution. It's fun. So cheat sheets. I think making a cheat sheet is a really good exercise when you're studying for interviews. It doesn't really necessarily matter how long it is, just that you start trying to process the information. So I've provided this cheat sheet. It's sort of an example of what I would have for arrays. And Meg did mention that my numbers for arrays are a little bit different. And this is because of how I think of arrays. So I'll talk about that a little bit after, just to clarify why my numbers might be a little bit different. So I'm going to stop recording and open it up for any more questions.